Okay, so today we're going to continue going over comparing fractions. Yesterday you guys compared fractions with the same denominator, okay? So like 3/8 and 4/8. Which one was greater, 3/8 or 4/8?
4/8.
4/8 was greater, okay? 2/4 and 4/4. Which one's greater?
4/4.
4/4, okay? But today you're going to look at comparing fractions where the denominator is different, okay? And when I say denominator, I'm talking about which one? The bottom. Good. Okay, so first thing we want to do is look at some fraction strips on our math chart. And we're going to label these together. So the very top one is not cut into any pieces, right? So what would we label the top one?
One whole.
One whole. Good. Okay, the second row, each piece would be 1/2. Good. So this would be 1/2, 2/2. And I'm doing my line sideways so I have enough room because I write kind of big. Okay, the next row is cut into 3 bars, so we would label each piece
1/3.
1/3. Good. So this would be 1/3, 2/3, 3/3. Okay, the next row, 1/4, 2/4, 3/4, and 4/4. Okay, the next row, I see 1, 2, 3, 4, 5 pieces. So now the denominator becomes 5. So we say 1/5, 2/5, 3/5, 4/5, 5/5. Okay, the next one, 1, 2, 3, 4, 5, 6. So each one of these has a 6 as your denominator. Okay, and we're not going to try to label these skinny tiny pieces, so we'll stop here with this row. What would my denominator be on this row?
1/8.
Is there 8 pieces? Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8. So it's 8ths. So 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8. Okay, so there's a couple things I want you guys to notice. First, let's look at all of the end pieces. Okay, all of the end pieces. What do you notice they have in common? Sorry, Bryson. What do you notice? The bottom's 8 and the top is 8. The bottom is 2 and the top is 2. So to equal a whole, which is this whole length, you have to have the numerator and denominator be what? Equal. Okay? So 2/2 equals a whole. 3/3 is a whole. 4/4, 5/5, 6/6, 8/8. Those all equal what, class?
A whole.
A whole. Okay? But that's not what we're focusing on today. I just wanted y'all to see that and know what equals a whole. We should already know that, but now another thing I want you to notice is look at the pieces as you go down. What's happening to the pieces?
It's bigger.
As you go down, the size of the pieces, what do you notice? Kelsey?
They're going like sideways.
They're going sideways, yes. Aaliyah? They get smaller. So if my denominator is big, like an 8, the piece is actually going to be what? Smaller. So look at my denominator here. It was low. It's a 2. But my piece ends up being bigger. Why do you think that is? how could I explain that this piece is bigger than this piece and the denominators are smaller when they're bigger? Kelsey?
So every time they go like sideways, like it's starting from 1 all the way to 8, it like goes in number. It like goes in number form, 1 to 8.
Okay, yes, it does do that, but the reason this piece is bigger is because it's only cut into 2 pieces, right? As you get lower, the more pieces you cut it into, the smaller they get, right?
Yep.
So what that means is, so the higher denominator actually means the pieces are what? No, not higher. See, an 8 is the highest denominator that we have here. Evangeline, are you paying attention or are you too busy erasing things? Okay, so 8 was the highest denominator, but this piece ended up being smaller than this one. Okay, so a higher denominator actually means what? Smaller pieces. Okay, so those of you at home, if you're watching this, we are going to write this in our notebooks now. Okay, so we need to get out our math spiral and we're going to write some notes down real quick before we start our lesson. Okay. Okay, so this is where we left off yesterday in our notes. We said to compare fractions where the denominators are the same, all you needed to do was look at the numerator. Javea ate more because she had 5 on the top and Aaliyah only had 3. Okay? So I want you to kind of draw a line underneath that, and we're going to start a new part to our notes. Okay? So now we're comparing fractions with different denominators. So let's say we have 2/3 and 2/8 that we're comparing. Okay, so now we need to circle the denominators. Everybody look at the denominator, 3 and 8. We said on our chart that when we went down, the denominator got higher, but the pieces got what?
Lower.
Smaller, okay? So the higher denominator actually means this is going to be smaller. Okay, so let's look at it as pizza, because that's probably the most common used example. Pizza, pie.
Apple.
Okay, so I'm going to try my best to draw equal holes, meaning our circles need to be the same size. We can't compare them if our holes are not equal. Okay, now I need to make this one cut into how many pieces?
3 pieces.
3 pieces. Okay, so remember that looks like a peace sign. We go down about halfway and then out. Okay, and now I need to shade how many pieces?
2.
2. Okay, so those of you at home, make sure you're copying this down in your notes with us. Okay, now over here, I need to cut this pizza into how many slices? 8. Good. So to draw 8s, we go down to make a cross, and an X. So try the best you can to make all your pieces equal. Cut this in the middle, going down like an X, and down through the center, and then we need to shade 2 pieces again. 1, 2. Now what do you notice already between these pieces over here and these pieces over here? What's going on there? What could you say about those slices? Bryson?
The first one is 1 out of, or 3 out of 2. 2 out of 3.
Well, yes, but what do you notice about the size of the pieces? Evangeline?
3 ones. The 2 pieces are bigger than the 2 8.
Good. These pieces are much bigger. Okay? These pieces are smaller. The reason they're smaller is because we had to cut it up a lot more times, right? We had to make 8 pieces instead of only 3. So the more you cut it up, the smaller those pieces are going to get, right? If I have a birthday cake and I have to just split it between me and my mom, well, we're going to get big slices, right? Because I'm only cutting it in half. But if I have to share my cake with 10 people at my party, well, I'm going to have to cut the pieces smaller, right? Because I've got to make more slices, okay? So the bigger denominator means your pieces are going to be smaller, okay? So that's what we need to write. Bigger denominator smaller pieces. So the higher that denominator gets, that tells me that those pieces are going to be smaller, okay? Bigger denominators. Okay, so now we're done with our notes. We're going to look in our books, page 75. 75, volume 1. Okay, so now we're comparing fractions where the denominators are different, but the numerators are the same, okay? So let's look at the first word problem. Kelsey, will you read that for me?
Josh is at Enzo's Pizza Palace. He can sit at a table with 5 of his friends or at a different table with 7 of his friends. The same size pizza is shared equally among the people at each table. At which table should Josh sit to get more pizza?
Okay. Okay, so let's look here. There will be 6 friends sharing pizza A. Okay, so here's pizza A. Because there's 6 people sharing it, they've cut it into how many slices? They cut it into 6 slices, okay? Pizza B, because there's 8 people sharing it, they've cut it into 8 slices. Okay, so let's shade 1/6. And shade 1/8. What do you notice about these slices?
Ooh.
Kelsey?
They both have a numerator of 1 on top.
Good, the numerators are the same, denominators are different. What did we just write in our notes about the denominator? If it's bigger, then that means the pieces are actually smaller. So who is going to, or which piece is bigger? 1/6 or 1/8?
1/8.
1/6 is bigger. If you look at the shaded part, does that look like a little bit more is shaded than right here? Yes, okay. So we need to label this as being bigger. Go ahead and label it because that's going to help us because sometimes it's confusing. We've got too much in our brains to remember. Okay. You can look at the picture and see that it's bigger, and you can also look at the denominator. If the denominator is smaller, the piece is actually going to be bigger. Okay? So now we need to figure out which way our symbol goes. If 1/6 is bigger, then that means my mouth needs to be open towards it, right? Like it's going to eat it. Okay? So your mouth needs to be turned this way. So we would read this as 1/6 is what, class? Greater than 1/8. Okay? So if Josh wants to get the bigger piece, which table should he sit at?
1/6.
This one, right? So the table with 5 friends. Because he has less people he has to share it with, right? If I have to share it with more people, then I know my pieces are going to get smaller. Okay, number 1, which pizza has more pieces?
Ooh,
It's not a trick question. Everybody call it out.
pizza A.
Which pizza has more pieces?
Pizza A. Pizza.
Pizza B has more pieces, right? Okay. So the more pieces a whole is divided into, the blank the pieces are. What do you think goes there? The more pieces I've divided it into, bigger or smaller?
Bigger. Smaller.
Smaller. The smaller the pieces are. Number 2, which pizza has fewer pieces? A. It only has 6. The fewer pieces a whole is divided into, the bigger the pieces are.
They're opposite.
It is opposite. So now, when the denominators are different, you have to train your brain to think the opposite. If that denominator is really high, like a 10 or a 12, then those pieces are actually going to be small, very small. Okay? Flip the page. Now here's the fraction strips, like what we looked at. So we looked at the fraction strips on our chart, and we drew circles in our notebooks. Okay, so now let's compare 2/8 and 3/8. 2/8 and 3/8. On Saturday, the campers paddled 2/8 of their planned route down the river. On Sunday, they paddled 2/3 of their route down the river. On which day did the campers paddle farther? Okay, so we want to know which fraction's more, right? 2/8 or 2/8 or 2/3. So let's shade our fraction strips. Javea, how many should I shade for the 8s? 2. 1, 2. You guys don't have to shade it in super dark. Just lightly shade over it. Okay, and then how many should I shade here, Bryson?
2.
2. Now, if I just look at these pieces, can I tell which one's bigger?
Yes.
Which one?
The bottom.
Bottom one. So let's circle that and label which one's bigger. 2/3, because lower denominator means the pieces are bigger. Okay, so now we need to put our symbol in right here. Which way would my symbol go? I want you to hold your hands up. Should be going this way, right? It should be eating 2/3, right? Because the alligator mouth wants to be open towards that bigger piece. So the campers paddled farther on which day? Well, let's go back and see. 2/3 goes with which day?
1/8.
Which day? 1/8 is not a day.
First day? Sunday.
Sunday. Thank you, Aaliyah. Hello, people. Oh, and see, look at me. Now I'm writing Aaliyah. Aaliyah's not a day either. Sunday. We have to make sure we're answering the question that is asked. It says which day, so we can't put 2/3 because that's not a day. We can't put Aaliyah. We can't put 2/8. None of that answered the question.
Can we do that one by ourselves?
Okay. Let's do one more together, and then you guys can do 2 and 3 by yourself. Okay. Number 1 says shade the models to show 1/6 and 1/4. So shade your pieces. Okay, can you tell just by looking at the shaded parts which one has more shaded? Bryson? 1/4. So label it bigger. 1/4 is bigger, right? You also can look at the denominators. Bigger denominator means smaller pieces. Okay, so I want the bigger piece. Now let's put our symbol in correctly. Which way should the symbol go?
Oh, it should go.
Just hold your hands up. I can see. Good. The mouth needs to be open towards 1/4. Okay. Now what if we have no pieces to shade? I have 1/8 and 1/3. I have no circles and no strips to help me. What am I going to do, Bryson?
Look at the bottom number.
Good. Look at the denominator. So everybody circle your denominators.
The biggest one is what? You're doing it out that way because there's 8 on this side of it.
No. You circle the denominators. Remember, the higher denominator actually means the pieces are what? Smaller. Okay? So let's label 1/3 as being bigger. Okay? Okay. For some reason, it helps us to label it bigger, right? Now we want our mouth to be eating that bigger one. So I need to face it going, the big part facing 1/3. Okay? So that's what I want to see on your paper. I want you to circle the denominators. The one that's actually lower is going to end up being bigger. Okay? We have to train our brain to think the opposite on these. Okay? So now I want you to try 3, 4, and 5 on your own, and then we'll come back. Okay, now let's go ahead and check. So I'm circling the denominators. The lower one means it's what? Bigger. Okay, so the mouth on this one should be facing this way. 3/4 is greater than 3/8. Okay? Over here I have 6 and 3. What does that tell me? Kelsey?
It will be going this way.
Good. 2/3 is bigger. Okay? So your mouth needs to be eating 2/3. So I would read this as 2/6 is what?
2/6 is
Less than 2/3. Good. Okay, and here they're equal. 3/6 and 3/6 are the exact same. Okay? Number 6. Zach has a piece of pie that is 1/4 of a pie. Max has a piece of pie that is 1/2 of a pie. Max's piece is smaller than Zach's piece. Explain how this could happen. Draw a picture to show your answer. Okay, so do we want to draw circles or do we want to draw strips?
Strips.
Okay, now if we're going to draw strips, this is how you do it. You're going to go over here out to the side and draw a long skinny rectangle. And then you're going to draw another one right underneath of it. The reason we do right underneath is because that helps us make sure that they are equal. Because we can't compare them if the whole pieces are not equal. Okay, so I have Zach and Max. So I'm going to label Z and M. Zach's piece of pie is 1/4. So I need to take his bar and cut it into how many pieces?
Cut it in. Zach needs to be one.
4, right?
Yeah,
4 pieces. So let's cut right down the middle. And then you're going to cut in half of that. So draw a line in between those. So what I did was cut right down the middle and then cut that piece in half. Here and here. Okay? Now, Max.
What half?
How do I draw Max's strip? Tavea, what do you think? One line, good. Just right down the middle, right? So Max is eating 1/2. Zach is eating 1/4. Max's piece is smaller than Zach's piece. Okay, everybody got that shaded?
Yep.
Max's piece is smaller than Zach's piece. Is that right? No. We can see here that Max is more. Okay? So how can we explain this? Explain how this could happen. What do you think, Bryson? Did you have your hand up? Okay, well Max probably thought he was getting less because the denominator was 2, right? He thought he was, but he's actually getting more because it's only cut into 2 slices. So that means the pieces are actually bigger, okay? Max's piece is actually bigger. Because his pie is only cut into 2. The pieces are bigger. Okay, so the smaller denominator actually means the pieces are bigger. So Max, he must have just got confused. He thought, well, I'm only getting 1/2. 1/4 seems like more because 4 is bigger than 2, but really, it's the opposite. Right, Allie?
It just sounds like
It sounds like he's getting less, right, Bryson, but he's not.
he's getting less. He's getting less.
Because you can see on the picture we drew,
There's 2 pieces.
we had to cut it up more times, so those pieces got smaller the more we cut it up. And I could go on and write a whole big paragraph about that, but I think you guys get the idea, so we're not going to write all of that down. The pieces are bigger when you only have to cut it into 2 slices. Okay? Okay, let's flip. Once you get that written down, flip to page 78. Last thing. What do we always do?
Do it by yourself.
Yes, ma'am.
Then check over.
Do it by ourselves. 9, 10, 11, 12, and then we check over it. So do 9, 10, 11, 12 once you get this written down. Okay, checking our answers to numbers 9, 10, 11, 12. Number 9 says Ben, Laura, and Liz had pizza for lunch. Ben had a slice of the mushroom pizza. Laura and Liz each ate one slice of the olive pizza. Which fraction shows how much pizza Ben ate? Okay, so Ben ate the mushroom, right? So how are we going to figure out how much Ben ate? Kaylee? Count how many pieces in all on the mushroom? Good. So there's 1, 2, 3, 4, 5, 6. So that means the denominator is 6. He ate 1. So A would be the correct answer. Which symbol makes this statement true for number 10? 2 6 is blank, then 2 8s. Okay, well you had to look at the denominators. Which one is bigger? Which fraction is bigger, Kelsey?
6 because there's bigger pieces.
Good. So this fraction is bigger. The fraction with the higher denominator actually means the pieces are smaller. So the symbol should be eating 2 6 like this. So B was correct. Okay, any questions so far? No? Okay, number 11. 3 more friends joined Ben, Laura, and Liz for lunch. Mike and Tom each had one slice of the olive pizza. Grace had a slice of the mushroom pizza. After all of the friends had eaten lunch, which statement is true about the slices of olive and mushroom pizza that were left? Okay, so that were left means we're comparing how much, not how much they ate, but how much they did not eat, right? Okay, so let's look at the mushroom pizza. I know Ben ate one slice. Okay, and then it said Grace had a slice. So I shade that. Mike and Tom each had a slice of olive pizza. So I take that out and that out. Okay, so now we're comparing how much is left. So let's look at the mushroom. How many pieces are left? Allie? Are left, Aaliyah? 4 out of how many total? 6. Good. And over here, Javea, how much was left? It's not a trick question, guys. Look at the pizza. How many pieces are left? Say that again. 4. 4 out of how many? 8. Good. Okay, so these are the two fractions we should have been comparing. Which answer choice shows the correct fractions? C. You didn't even need to worry about the symbol because these two are the only ones, is the only answer choice that has the correct fractions. These 3 are incorrect. Okay? So you had to make sure you were comparing the pieces that were left. Not how much was ate or eaten, but how much was left. Okay? Last one. Before taking a hike, Kate and Dylan each ate part of the same size granola bars. Kate ate 1/3 of her bar. Dylan ate 1/2 of his bar. Which of the following correctly compares the amounts of granola bars that were eaten? Okay, I look at them. Is there any that I could automatically eliminate? Evangeline? D. Okay, anything else? Okay, well the rest of them have the correct fraction, so now we just need to figure out which way the symbol goes. So I have 1/3 and 1/2. We look at our denominators. Bigger denominator means smaller pieces. So which fraction's bigger?
1/3.
Which fraction's bigger? 1/2. Okay, so this one's bigger. So the mouth needs to be open towards 1/2, right? We want to eat the bigger fraction. Now I need to find which one shows the mouth eating 1/2. Is the mouth eating 1/2 here? No. B? No. C? Yes. It doesn't have it in the same order I do, but it has the mouth facing the right direction. Okay? Any questions on comparing fractions? Because you're about to do this all on your own.
No. Why did you X the answer?
Oh, did I X the answer? What? C was correct. Sorry. Bubble it in, not X it out. Okay? All right, so for your assignment, practicing more on what we just went over, you're going to tear out page 79 and do front and back. Okay? Last chance for questions before we go on. Nobody has a question. Bless you. Okay.